You've probably heard the word blockchain thrown around a ton, but what is it really? At its core, it's just a chain of digital blocks. So to get how the whole chain works, we first have to understand a single link. Today, we're going to crack one of those blocks open and see exactly what makes it tick.
So what's really going on inside one of these blocks? I know, it sounds super complex, but you're about to see it's built on just a few simple and honestly very clever ideas.
Think of it like this. Before you can build that epic Lego castle, you got to understand how one single Lego brick works. Well, for blockchain, the block is that brick.
And it turns out, any block, no matter what it's for, can be broken down into 4 essential parts. We're going to build one right now, from the ground up, so you can see exactly how it all snaps together.
All right, let's do it. Let's deconstruct a block and take a look at these 4 key pieces.
So here's the game planner. We'll start with the easy stuff, the block number and the data it's holding. Then we'll get into the 2 pieces that are absolutely critical for security, something called a hash and then the previous hash. Let's tackle them one by one.
Okay, first up, and this one's super simple, the block number. Every block has a number, starting with block 0, then block 1, block 2, and so on, forever. It's just like page numbers in a book. It's there to keep everything in the right order.
Next up is the data. You can think of this as the whole point of the block, right? It's the cargo it's carrying. For something like Bitcoin, this would be a list of transactions, who sent what to whom. But really, you can store any kind of digital info in here.
Now, before we add our third piece, we need to pause and understand a really important term, a hash. A hash is just a unique 64-character code, and it's generated from all the other info in the block. The absolute best way to think about it is as the block's unique fingerprint.
So part 3 of our block is the hash itself. And the most important thing to get here is that every single block gets its own unique hash. Just like no 2 people have the same fingerprint, no 2 blocks have the same hash. And here's the real kicker. If you change even one tiny little thing inside the block, the data, the number, anything, that fingerprint, the hash, changes completely.
And that leads us to our 4th and final component, the previous hash. This is the secret sauce. This is the piece that turns a boring list of blocks into a secure, interlocking chain.
So we have our 4 parts all laid out. But how do they actually work together to form a chain? This is where the magic really happens.
The previous hash is basically the glue that holds the entire blockchain together. Each block doesn't just have its own fingerprint, it also keeps a copy of the fingerprint from the block that came directly before it.
Let's look at how this builds the chain. So here on the left, we've got block number 2. If you look inside its previous hash field, what's in there? It's the unique fingerprint from block number 1. Then look at block number 3 on the right. It does the exact same thing. It stores the unique hash from block number 2. See, each block is pointing back to the one that came before it.
The source material we're looking at puts it perfectly. It says, this previous hash binds one block to another, just like a chain. That's not a metaphor, it's literally what's happening. This is what puts the chain in blockchain.
Okay, this all makes sense, but it does bring up a pretty logical question, right? If every single block has to point to the one before it, what in the world does the very first block in the chain point to?
Well, that first block is special. It's so special it gets its own name, the Genesis block. You can think of it as the granddaddy of all the other blocks that will ever be created on that chain.
So what's in its previous hash field? It's actually super simple. Since there was no block before it, the value is just 0. Or a string of zeros. It's the only block in the entire chain that's allowed to do this.
So, to make it official, the Genesis block is simply the very first block in a blockchain. It's what kicks the whole thing off, and it's uniquely identified by having a previous hash of 0.
Okay, so we've built a block, we've linked them together, but so what? Why go through all this trouble with hashes and previous hashes? Why does this whole structure matter so much?
Well, it all boils down to this. Number 1, every block has that unique fingerprint, its hash. Number 2, every block points to the fingerprint of the block that came right before it. And number 3, when you combine those 2 facts, you create this incredibly secure, interlocking chain of information that's extremely difficult to mess with.
And that leaves us with one last really crucial thought. If every block is cryptographically tied to the one before it, what happens if someone tries to tamper with the data in just one block? Well, think about it.
If you change the data, that block's fingerprint, its hash, is going to change completely. And that new hash won't match the previous hash that's stored in the next block. The chain would instantly and obviously break. That interlocking structure, that is what makes a blockchain so remarkably secure and tamper-proof.